For part A, the wavelength is given in kilometers, which I will change to SI units. So that would be 4 times 10 cubed meters. Also, we are told that it's traveling through air, and that's important to know because that will provide us the speed. Since it's an electromagnetic wave, all electromagnetic waves travel at the same speed. And through air, that speed is approximately 3.0 times 10 to the 8 meters per second. The goal is to find the wavelength. No, it's not. The goal is to find the period. So the speed of a wave is equal to lambda times f. However, there's a relationship between the frequency and the period. They're just reciprocals of each other. So the speed of the wave is really lambda times 1 over the period. That can be rearranged for the period. It'll end up being lambda divided by v. Lambda is in meters, speed is in meters per second, so the units are going to end up being seconds, which is what's expected. That's the SI unit for times or periods. So 4 divided by 3 is 1.3 repeated to 2 significant digits. That's 1.3. And then with exponent laws, we can get 10 to the negative 5 seconds. If you're interested in prefixes and all of that, I believe that would be 13 microseconds. A microsecond is 10 to the negative 6 seconds. Anyway, part B. If this wave entered a pool of water, so the speed of electromagnetic waves in water is slower than through air. It slows down to 2.25 times 10 to the 8 meters per second. What would the new period be? What would the new wavelength be? So this is testing a key concept in terms of the period. Period is the reciprocal of the frequency. The frequency is determined by the actual vibrating object that's producing the wave in the first place. I'll say it's determined by the vibration. And the medium does not affect the period. So just because this enters the water, the wave enters the water, that does not change how frequently the object is producing the vibration. So the medium will not change the frequency, and therefore the medium will not change the period. But how about the wavelength? The wavelength will change. So if we go back to the equation we had, period equals wavelength over the speed. This time we're going to be rearranging for the wavelength. So it'll be the speed times the period. And I'll use the new speed, the speed in water. But I'm going to keep the same period because the period is not affected by a change of medium. So 2.25 times 4 over 3, 1 in the third. That gives me 3. And then exponent laws, 10 to the 8 and 10 to the negative 5 produce 10 cubed meters. So the wavelength got shorter as it went into a slower medium.